In this video, we'll discuss how to use the method of finite differences to write rules of sequences that are greater than linear. In other words, that are maybe quadratic or cubic. So basically not arithmetic sequences, not geometric sequences, but higher order functions. If you were, tasked to write the rule that generates this first sequence, one of the first things you would probably do is notice that you're just adding two successively. So that's called a common difference. We know that. And we can identify this sequence as an arithmetic sequence because it has a common difference. We can identify that a linear model can be modeled to generate this sequence. It would look something like dn plus c, where d is that common difference. In this particular case, you'd be looking at 2n minus 1. But the big thing is that to remember that a linear model is a first-degree polynomial. And so this is called a first common difference. So the fact that this sequence has a first common difference means it's a first-degree function. Now, keep that in mind. Let's look at this guy. 3 to 5 is 2. 5 to 8 is 3. 8 to 12 is 4. 12 to 17 is 5. 17 to 23 is 6. Now, that does not have a common difference. It does not have a common ratio either. There's no common multiples there. But what you can see is that these are all separated by 1. This is called a second common difference. And a sequence with a second common difference can be written as a second-degree polynomial function. And a second-degree polynomial is also known as a quadratic. Also known as, x squared. You can have an x squared, or in this case, not an x squared, but an n squared, somewhere in this model. So for the rest of this video, we're going to examine ways to actually write out that equation. So let's check it out. Here's a general quadratic sequence. What I mean by that is I kept everything in terms of n and a and all that kind of stuff. And I want to actually write out the first 4 terms of this sequence by plugging in 1 for n, by then plugging in 2 for n, 3 for n, and 4 for n. So let's go for it. Now, if I plug in 1 for n, a times 1 squared is just a. B times 1 is b. C times 1 is nothing. It's just c because there's no n. Let's do the same thing for 2. Put in 2 for n. N squared is 4 in this case. 2 squared is 4. So that's 4a plus 2b plus c. Put in 3 for n. A times 3 squared is going to be 9a plus 3b plus c. And you see the trend, 16a plus 4b plus c. Now, let's see what's going on here. Let's subtract. Let's find a common difference. Let's do 4a minus a. You get 3a. 2b minus b. You get 1b. And c minus c is of course 0. 9a minus 4a is 5a. 3a, of course, is minus 2b is b. C minus c is 0. 16a minus 9a is 7a. This is b, of course. So that's the common difference amongst those two terms. Let's do this one more time. What we're going to see is we're going to have a second common difference. We know this is quadratic. So 5a minus 3a is 2a. 7a minus 5a is also 2a. So this is a second common difference. Hooray! It worked out nicely. Now, what do we go through this whole process for? Well, we did it for a system of equations. This is a system of equations now that will allow us to write the sequence of any quadratic model. Here's how you're going to do it. Let's actually write out this sequence and do the whole common difference thing with it. So, here's the sequence, 1, 10, 23, 40. And look back here real quick. Let's find our first common difference, 9, 13, 17. Let's find our second common difference. I'm just going back here to make sure I'm color-coded accurately. This is 4, and this is 4. So now I got these 4 purple numbers, I got these 3 red numbers, and I got these 2 green numbers. And what these numbers will all allow you to do is to solve for A, B, and then C, and that will allow you to write this general quadratic this sequence here. So let's look right here. Here, this is 2A. So therefore, this is 2A. We can solve for A immediately. 2A equals 4. A equals 2. So that's going to be the coefficient of n squared. Now, let's go to red. Again, I can choose any of them. I'm going to use the top level one because those are the smallest numbers on my general here. So 3A plus B, we're going to set equal to 9. Plug in, substitute in my value of A here, and solve for B. 9 minus 6, B equals 3. And now, go back to purple. A plus B plus C is going to be equal to 1. Plug in my value of A, plug in my value of B, solve for C. So C is equal to negative 4, 1 minus 5. And so what that means, A, B, and C, just like in the quadratic formula, A, B, C here, that means that this sequence, the rule for this sequence that generates this sequence is A n squared plus B n plus C. And I don't know about you, but I would never have come up with that had I not gone through this process. Of course, you can check, right? If I find the second term of this sequence by plugging in. So the second term of this sequence is 4 times 2 plus 6 minus 4, 8. Plus 6 is 14, minus 4 is 10. And all is well and good with the world, because this one worked out beautifully.